In this particular section, we are going to discuss about real numbers. Now, before diving into what real numbers really are, so we're going to start our discussion with a type of number. They are known as natural numbers. Natural numbers are usually referred to as countable numbers. So the countable number means if we consider our hand, so how it's the smallest number that we can count using our fingers. So the smallest number that we can count using our fingers will be 1. Then the next number that we can count will be 2, 3, 4. This goes on and on. So going on and on is denoted by this ellipsis. So this means that this number sequence is going to go all the way up to infinity. So that means it's going to go on and on. It's never going to stop. So natural numbers, you can think of natural numbers as a collection of numbers where the lowest countable number is going to be 1. So these are what natural numbers are. Now we can ask, like, isn't 0 a natural number? No, indeed it's not a natural number. That's because you cannot count 0 using our fingers. So 0 is a very special kind of number, so it does not have any value in the sense that we cannot count. So whenever we say that in counting, whenever we say that it's 0, so that means there's nothing to count. So that is going to fall under a different category of numbers. We are going to call it whole number. So if we include 0 to our collection of numbers, natural numbers, so we can say this is another set. So here we are taking into account the number 0 along with the counting numbers. So this becomes a bigger collection. So we are going to call this bigger collection a number which starts from 0, 1, 2, 3, and it goes on and on. So this bigger set of number is going to be referred to as a whole number. So this is the bigger collection. It's the collection of numbers that includes 0 as well. Now we're going to consider another set of numbers. Now if you remember, there's something called the additive inverse. So additive inverse means given a number, let's say a, given a number a, when we add some number also known as the additive inverse to this particular number a, that's the result is going to be equals to 0, and that's the whole idea why the 0 was introduced and for this particular lecture. So what's that number going to be? So what we can do, we can use the laws of arithmetic. So we have to get rid of the a on the left hand side. So to do that, what we'll do is we'll use subtraction. So we're going to subtract a from both the sides. Now that means this a minus a gets cancelled. So that means we are now left with the unknown on the left hand side, and 0 minus a, we know that 0 doesn't count. So that means we're going to get negative a. So we're saying that this negative a is the additive inverse of the number a. This is the additive inverse of a, so that when we add this additive inverse to a, the result is always going to be 0. So that means each of the natural number is going to have an equivalent additive inverse. So that what I mean to say, for the number 1, the additive inverse will be -1, such that when we add 1 to -1, we get a 0. Similarly for 2, we're going to have an additive inverse, so that will be -2. For 3, that will be -3, and for 4, -4, and the list goes on. So here these are called negative numbers. So what we have done, we have introduced a new collection of negative numbers. Now when we consider this much bigger set that contains the natural numbers, the whole numbers, as well as the negative numbers, then this entire set is now going to give us a new set of numbers. They are known as integers. So in simpler terms, we can think of integers as a collection of numbers that contains all countable numbers, that is the natural numbers, it contains 0, and it also contains all the negative numbers. So a collection of positive and negative numbers including 0 are referred to as integers. Now that we're familiar what integers are, so let us introduce another type of number. So we're going to start with, let's say, two integers. Let one of the integer be called a p. It could be any integer, positive or negative. And we have another integer, q, be two integers. Now, this particular integer, when we write in a format as p divided by q, we can say q divides p, with the condition that the denominator is not equals to 0, because we cannot divide by 0, then this particular type of number, p over q, is known as a rational number. But then generally we are more familiar with the name, the fractions. So these are our fractions are rational numbers. So we have the number half. So we could have 2 over 7. We could have 3/5. So these are all examples of rational number. We could even have negative rational numbers as well, because the condition is that p and q could be integers. So we could have negative 2 over 3. So this is also a rational number. So this rational numbers, this can be expressed in another form. That form is known as decimal number. So any given rational number can be expressed as a decimal number. So if we take the first number half, so its decimal equivalent will be 0.5. If we consider the third number, 3 divided by 5, so that will be 0.6. So here the decimal number, it's a terminating decimal number, in the sense that after the number 5, there's no other digits that's coming over here. So it's complete. So it's a terminating decimal number. Similarly, when we divide 3 by 5, so what we're going to get is 0.6. Now if we look at the fourth number, which is negative 2/3, now we are going to see that when we divide 2 by 3, what we're going to get is negative 0.666. Now what is going to happen? It is going to go on indefinitely. That means it's non-terminating. So this is a non-terminating decimal number. Similarly for 2 divided by 7, so this is also going to be a non-terminating decimal number. Here there's a very special about this particular decimal number. So this value is going, it's 281,754, and after that it's again going to repeat. It's again going to be 281,754, and this is going to happen over and over again. So this is also a non-terminating decimal number. So all these examples, the fraction numbers and decimal numbers, so they fall under the category of rational numbers. So now we have understood what rational numbers are. So let's put it in the box. So these are the numbers that could be fractional or in the decimal form. But whenever they're in the decimal form, we have to be sure that they are either terminating or they could be non-terminating. But also whenever it's non-terminating, it has a particular sequence to it. Now we'll come back to this particular idea a little while later. Now we're going to talk about a different kind of numbers known as irrational numbers. Now irrational numbers are those numbers which do not follow the pattern as followed by rational numbers. So any number that is not rational is going to be an irrational number. Let's give you an example. The square roots. The square root of 2, this is an irrational number, because if we plug in this particular value into a calculator, so it's going to give us 1.414, and we can see it is non-terminating, that's for sure. So that means the digits are going to go, it's never going to stop, it's not going to terminate, it's going to go on and on, but there's no fixed pattern to it. Now if you remember 2 divided by 7, it has a pattern to it. So it was 0.281754, and again after the end of the 6th digit and the 6th decimal place, so again the digits repeated, 281754. But here, when we're considering irrational numbers, there's no pattern to it. It's happening randomly. It looks as if it's having a random. It's having the patterns are repeating randomly. So these such numbers are called irrational numbers. So there's another irrational number, the most famous one, which is our pi. So you can see that the pi has non-repeating, non-terminating decimal. So that means it's 3.141592653. You can see there is no sequence to it. So it's going to go on, and it looks almost random that how the digits are coming. So this is such numbers are called irrational numbers. So we have talked about 5 different types of numbers: natural numbers, whole numbers, integers, rational numbers, and we talked about irrational numbers. So we have 5 different types. Now when we put them under a very big collection, let's say a collection of numbers that includes all natural numbers, all whole numbers, all integers, all rational and irrational numbers, then this entire collection of numbers is going to be referred to as the set, or we can say the collection of real numbers. So that's it. So this is what real numbers are. So they have these 5 categories of numbers. So let's summarize whatever we have learned so far on a line number. So it's a line number is a straight line that consists of all the numbers that we can think of. So we are going to divide this particular line number into 2 parts, into 2 equal parts. So let's divide it in the middle, and in the middle we are going to call it 0. And we are going to use the convention that to the left of 0 will be all negative numbers, to the right of 0 will be all positive numbers. So this 0 is what was a part of the collection of whole numbers. What we can do, we can divide this entire line numbers into equal parts. So let's say we divide it into equal parts on the both sides. So and we are assuming that the length of each division is 1 unit. So this will be 1, 2, 3, 4, 5. And for the left hand side, we'll have -1, -2, -3, -4, and -5. So this particular set or this particular collection of countable numbers will be natural numbers. If we are including 0 along with the countable numbers, we're going to get whole numbers. And if we consider the negative numbers as well, so let's call it this, we consider this particular section of negative numbers and include it with the whole numbers, then we are going to get where this and this is going to give us addition. In the sense, you're not adding here, I'm just saying including. So that means we'll get integers. So fractional numbers are the numbers that occurs between 2 integer values, or can say 2 consecutive integers. So if we consider number 0 and 1, we can consider somewhere in between 0 and 1. So that's going to be half, or 0.5. So that is a rational number. You can pick up any 2 other consecutive integers. So let's pick up -3 and -2. So we can say that -2.7. So that is a decimal number which lies between -2 and -3. So this is a rational number. So all numbers lying between 2 consecutive integers are rational numbers. Then finally we have some numbers which lie very close to rational numbers. For example, let's consider the value pi. So we know the pi is not a rational number because it cannot be written in a fractional form or p over q form. So its number is 3.141592. So it goes on and on. But we're going to consider up to, let's say, 2 decimal place. So we have 3.14. That's the value of pi approximately up to 2 decimal place. So where is it going to lie? we cannot exactly pinpoint where it's going to lie, because if we zoom in, without zooming in, we'll know that it's the value pi is going to be greater than 3, because it's 3 point something, but it's going to be less than 4. So that means it's going to lie somewhere between 3 and 4. So what we can do, we can further divide this. We can zoom in and we can further divide the value 3 and 4, the line 3 and 4 into 10 parts, let's say. Let's zoom in. So here what we have done, we have zoomed in into the line, the number line. Now we are between 3 and 4. So what we've done, we have divided into 10 equal parts. So we have pi approximately 3.14. So where will be 3.14? So we know that this division will be 3.1, this will be 3.2, 3.3, so on. This will be 3.9. Now we know that this is going to lie somewhere between 3.1 and 3.2. Now again, what we're going to do, we're again going to zoom in. We're again going to zoom in here. So what we've done, we have further zoomed in between 3.1 and 3.2, and we have divided into 10 equal parts. So the division will be now 3.11, 3.12, 3.13, 3.14, so on up to 3.19. Now we know that we have to locate 3.14, so this should be this particular location. This is 3.14. However, this is not the exact value, the exact location of 3.14. This is an approximate, because then again we have, if we consider the value of pi up to 3 decimal place, so that will be 3.141. So that means we'll again have to further zoom in between 3.14 and 3.15. So it's very difficult to exactly pinpoint an irrational number. Anyways, you have got the idea. So irrational number is similar. It's when it comes to locating, it's very difficult, but that's how it's done. We can locate an irrational number also in a on a number line. So this is what is a real number mean. A real number is a set or all the collection of all the numbers, such as the natural number, whole numbers, integers, rational numbers, as well as irrational numbers. So that is going to be, so our entire real number line. This is also known as the real number line.